When solving a system of equations sort of problem with a word problem, you need to look to find the two things that you are being asked to find, those become your two variables, and then set up two different equations. Typically, both of those equations will conclude both of the variables that you are being asked to find. So in this first problem, the thing I'm going to be asked to find are when and where will these two hikers meet. That's going to be my two variables. But I want to think about what that looks like first. I basically have this situation. There is this trail, and Maria is at the top of the trail, at the trailhead, and Edna is down at the lake camping. Now Maria, at the same time, Maria is going to start hiking down the trail at an average rate of 2.5 miles per hour. Edna is going to start hiking up the trail, but because she's going uphill, she goes more slowly, and she's only going to average 1.5 miles per hour. The entire trail is 12 miles long, and they want to know where on this trail they're going to meet and when they're going to meet. So they're going to meet somewhere on this trail. I have to define that distance on the trail with the where, either as the distance from the trailhead at the top or from the lake at the bottom, and they didn't tell me in this case which one to use. So I'm going to define this distance from the lake. So this is x. So x is the distance from the lake where they meet. And then when, well, I'm going to use h as the number of hours they're hiking. Distance from lake in miles, number of hours they are hiking. If I use x as the distance from the lake, then let's look at Edna first because she's starting from the lake. Edna is going to travel at 1.5 miles per hour. To figure out how far she's gone, I'd take 1.5 times the number of hours she's been hiking. So she's been hiking for an hour and a half, I'd take 1.5 times 1.5. If she'd been hiking for 5 hours, I'd take 1.5 times 5. So I'm going to take the speed, as you know, distance equals rate times time, the rate that she's hiking times the time that she's hiking, which is h, equals the distance that she hikes, which is x. Maria's is a little bit different in that she's hiking at 2.5 miles per hour, so it's still 2.5 h, but her distance isn't x. If she hiked from the top to the bottom of the trailhead, she'd hike 12 miles, but she hikes x miles less than that because Edna hikes part of that distance, so 12 minus x. At this point, I can either use substitution or elimination to solve this system of equations. I'm going to choose to use substitution because x, I know, has a value of 1.5h, and so when I see a variable that's isolated like that, I like to use substitution. So where I see x in the second equation, I will substitute 1.5h in its place. So 2.5h equals 12 minus 1.5h. Now I'm going to add 1.5h to both sides of the equation to move the variable to the left and eliminate it on the right. And I end up with 4h equals 12. So then when I divide by 4, I get h equals 3. So it takes 3 hours for them to meet. Now as far as where they meet, I could go into either one of these two original equations and substitute the 3 in place of the h and solve for x. I'm going to choose to use the first equation because the x is already isolated. So 1.5 times 3 equals x, which means 4.5 equals x. Now I'm not going to write this answer as an ordered pair because I'm really supposed to answer the question that they are asking. So the question, when and where will they meet? They will meet in 3 hours, 4.5 miles from the lake. Now, if you chose to use x as the distance from the trailhead instead, your answer would have been they will meet in 3 hours, 7.5 miles from the trailhead because your equations would have been different. Either one of those is acceptable because it doesn't say where being distance from the lake or distance from the trailhead. This next equation, again, look for the two things they're asking you to find. How many cookies, oops. So they're asking me to find how many cookies and how many brownies did they sell. So my two equations, I'm going to use C is number of cookies sold, and B is the number of brownies sold. And then I go looking for the rest of the information they gave me. In this case, they give me two total amounts. They sold a total of 600 items and raised a total of 360. Those two totals are going to become the setup for my two equations. So one equation, something equals 600, the other one equals 360. Now, how do I do that? Well, they sold 600 items, so they sold some number of cookies and some number of brownies, so C plus B is a total of 600. To raise the money, if you look back at the problem, they charged 35 cents for every cookie, and they charged 75 cents for every brownie, so together, those prices, 35 cents times the number of cookies and 75 cents times the number of brownies, has to equal the total amount of money raised. Now, I could use either substitution if I isolated either this C or B, or elimination to solve this. Since one of the variables isn't already isolated, I'm going to use elimination. Since this is a positive 0.35 C down here, I'm going to multiply the first equation by negative 0.35 to create opposites. When I do that, I end up with negative 0.35 C from this first equation minus 0.35 B equals negative 210. Again, I'm just multiplying everything in this first equation by negative 0.35. When I combine these two equations together, the C's are eliminated. I end up with 0.4B equals positive 150, 360 minus 210, or 360 plus a negative 210. When I divide both sides by 0.4, I end up with B equals 375. So they sold 375 brownies. Now, going back to my original equation, my C plus B equals 600. I know now that B equals 375. So C plus 375 equals 600. And yes, show this work. Subtract the 375 from both sides to solve for C. So C equals 225. Again, I'm not going to write this answer as an ordered pair. I'm actually going to answer the question being asked. So they sold, using a complete sentence, they sold, oops, so they sold 225 cookies and 375 brownies. Again, notice that the two things they're asking me to find become my two variables, and I define those. That's required. I write two different equations that have both of those variables in them. I use one of the methods, either elimination or substitution, that I've learned to solve the system, and then I write one or more complete sentences to actually answer the question being asked. Now, before you come to class the next time, define your two variables for this, write your two equations, solve them, solve the system, and then answer the question being asked. Thank you.